Hello. Thank you. Well, I think that was unfair that I have to go after that. I'm ready for a nap now, but I'm going to be okay. So this is we're joining now, and I'm so my head is so full with all the information I've gotten from the previous sessions, and I'm about to burst. So actually, I guess it was good to have the session with Mallory. Thank you. So my name is Thomasine and Thomasine Dolan, and I work for MII. If you didn't figure that out already, I am the Director of Materials Innovation and Design here at MII. So thank you for joining. I'm going to jump right. I just want to back up because of that synthetics discussion that I really was found riveting, and I'm sure you all did too. Is that this panel, which we're about to start, is about scaling and the scaling challenge. And one of the things that that Sydney pointed out in the history lesson was that it took the scientists at DuPont about a decade before they could launch nylon. And that was one of a really major material revolution. And I just want to say, I feel like we're in that place right now. We are in a material revolution, and we've got material innovators who have been at it for 12 years, 10 years, and we're going to meet some who've been at it for less than 3 years. And they're actually moving quite quickly. So innovation does take time to do it right and to make it meaningful. Anyway, so at MII, we understand that brands and perhaps even consumers may be fatigued by waiting for the commercialization of these fabled next-gen materials and the fibers. Waiting, as most of us from the fashion industry know, is not in our vocabulary. Fashion, apologies for another fashion reference, I promise to move on, often relies on the new and the now, requiring short lead times. Honestly, many industries operate this way. Quicker is better. The current generation of textiles and materials have been running the show, delivering the goods, and meeting the needs of brands around the globe for a very long time without innovation or challenge until now. In this panel, we will meet innovators who are forcing a new material revolution. With sustainability as their driving platform, they have reimagined what can be done with plant waste, bacteria, kelp, and fermentation. We will dig into some specific challenges that come with each of these feedstocks, their material development, their production, and the manufacturing. We will also hear from a unique company whose sole focus is to help biomaterial companies scale. Each of our guests will give you some intel on the challenges that they've faced to get their ideas to market and what we can expect from this material revolution. And I would now like to introduce our speakers. And first, I'd like to introduce Joshua Lachter. Hi, Joshua. You can unmute yourself, please. Thank you. So Joshua is the co-founder, I know, classic. Joshua is the co-founder and chief business officer of Synonym Bio. Next up, I'd like to introduce Alex Gosiewski. Hi, Alex.
Hey.
Alex is good to see you. Alex is the co-founder and COO of Keel Labs. Next, I'd like to introduce Zimri Hinshaw. Zimri,
hey, everybody.
I see you finished with yoga. Okay,
Zimri.
I know. Zimri is the founder and CEO of Bucha Bio. And lastly, I'd like to introduce Martin Stübler. Martin is the co-founder and CEO of BioFluff. Hi,
hey,
Martin.
everybody. Hi.
Well, it's great to see you all. Thank you so much for being here, taking the time. And I'd like to go around, and we'll just start with Joshua, then to Alex, Zimri, and Martin. I would love if you'd all just give a little bit of background about yourselves and how you got into what you're doing, why you're doing, and of course, about your companies. Thank you.
Thank you for having me, Thomasine, and thank you for MII for putting on a wonderful gathering. Hope to all be together next year. I'm Joshua Lachter, co-founded Synonym a little over a year ago. I'm here in New York City in Soho. I have a background mostly in finance and finance adjacent, and more recently in artificial intelligence. But my real love has always been and continues to be in biology. I think that biology is an extraordinary medium of creation, and it is, after all, what got us all here. I think that, many of the challenges that we're trying to solve at Synonym have been touched on by various other speakers over the last day. we believe that the promise of biology to fundamentally change how our supply chains work, our food, our chemicals, and indeed our materials, can only be realized if we have the infrastructure to do it. And it represents, we believe, the primary bottleneck that will separate these extraordinary things that all of us want to touch and feel in a conference room or at a conference like this, to actually being able to use them in our daily lives, to being ubiquitous in supply chains. And so until we can actually make the infrastructure available, and in our case, we're starting with large scale commercial fermentation facilities, we don't believe that these products will really be able to enter the mainstream. And so looking forward to talking a bit more about how we are doing that and working with companies like the ones that have been featured at the conference to get their products to market as fast as possible.
That's awesome. What you're doing is so exciting. I'd never even heard about somebody doing that before learning about Synonym Bio. It's really an amazing niche that you found, which is, I guess, not a niche anymore because you've turned it into something else. Alex, will you please tell us about yourself and Keel Labs?
Yeah, so I'm Alex Gosiewski. My background is actually in design, and through my experiences in the design world, it became really clear that there was limited access to better materials, especially ones that were going to have, a benefit on the end of life of the product as well. And so through kind of this awareness, it became clear that new and better materials needed to come to the market. So I co-founded Keel Labs in 2018. And what we're working on today is developing new innovations inspired by the ocean. So our core product right now is our seaweed-based yarn, and we've named it Kelson.
Great. Zimri, will you please go next?
Yeah, absolutely. Yeah, like Joshua said, it's an honor to be here. My name is Zimri Hinshaw. I'm the CEO and founder of Bucha Bio, hailing from Houston in the great state of Texas. And at Bucha Bio, we're combining plant and bacterial-derived ingredients that are compatible with melt extrusion and plastic extrusion anywhere around the world. We're starting with show rye. Big fan of Keel Labs branding. They've done a very, very good job. We'll make sure our trademarks are kind of following suit. So we got show rye, which is an alternative to animal leather and plastic. And we work with automotive, home goods and furniture and accessories companies. So it's an honor to be here.
That's awesome. Thank you. Hey, Martin. So tell us about yourself and about BioFluff.
Hey everybody. Calling from San Francisco today. My name is Martin Stübler. I am the co-founder and CEO of BioFluff, and I've been working with plant-based materials and, let's say, biotechnological applications for about a decade. I've worked before in, let's say, mycelium leather applications before founding BioFluff in 2021. And BioFluff's mission is really to replace all animal and all synthetic fur on the market, with a big focus now these days on replacing synthetic fur. We've heard earlier that the prices of fossil fuel-based materials are just very low, but we are anticipating that with our current scaling technology, we will be able to compete with them very soon. And yeah, super excited to be here. Thank you very much for having us, Thomasine.
Thank you. Thank you for being here. And that's a great way to finish up, because you finished with scaling technologies and addressing that. But before we get into some of those more technical things, I wanted to back up a little bit. And to back up for this crew is only backing up a couple of years, because it's honestly like what you've done in such a short amount of time is really, I would say, miraculous, considering, again, how long things usually take to come to fruition in the materials world and in the infrastructure world in Joshua's case. So I'd love it. I'm going to I have a lot of questions that I think I would like all of you to answer. I hope that's not annoying, but I think that it will create some interesting dynamics as we go through to see, because everyone has a slightly different response and situation. So I would love to start with Joshua. Can you tell me about the first challenge you faced in trying to take your hypotheses of basically creating like biomanufacturing and like getting people on board with you? Like, how did that go?
Yeah, there aren't good words yet for our industry, which is part of our challenge. That I think, and the food industry has dealt with a similar challenge, that people are naturally want to touch and feel and understand what you're talking about.
Mm,
And
yeah.
it's hard when you talk about words like synthetic or faux leather or things like that, which are all terms, or faux meat in the um, in the food world. And so part of the challenge has always been, and I assume it's the same for everyone here, figuring out how to even just talk about this stuff in a way that people understand and that resonates with people. I think a term that we're sort of cohering around, and I'll talk a little bit about how we directly address this with our first products at Synonym, but a term we're cohering around is this idea of the materials transition. So in much the same way that, mostly on account of a few pioneering individuals, one of whom owns Twitter, to talk about the energy transition. Everyone's talking about the energy transition. Everyone knows broadly that like fossil fuels are bad and we need to electrify everything. And there's some complexity around doing that, but no one's really talking about the materials transition, that we need to fundamentally change how stuff is made. And that indeed a second order effect of fossil fuels is the stuff that we have. Everything that we have around us is a product in some way of the fossil fuel economy that we live in. And so if we're going to get rid of that input, we have to change everything around us. And so this idea of the materials transition is an idea that's not yet mainstream, that we think will be, that we hope organizations like MII will come along with us on. We're fundamentally trying to build the infrastructure, not only for the materials transition, but for the food transition as well. Materials encompasses basically everything in these supply chains, and we think that we're trying to fundamentally build the infrastructure that will power that. And for us, the way we started was by cataloging what was out there. So if everyone's talking about how they're going to bring a new product to market and it's going to disrupt this incumbent fossil-derived stagnant industry, we had to first understand where they were going to produce. Everyone talked about the sort of bottleneck in capacity, but you actually have to understand what's out there. So like in a fossil fuel based economy, the number of refineries you have matters. I think we're all intuitively understanding this now in a post-COVID world where supply chain bottlenecks and all of these things stymied our daily lives. And so we understand that like the world we live in is powered by actual means of production. And if we're trying to usher in a new world with new stuff that requires a new means of production, where does that means of production actually live? We launched a platform we call capacitor.bio, which I encourage everyone to check out, that actually cataloged that biomanufacturing capacity. And only then, and I can talk more about this, but only then did we realize, hey, people weren't kidding. There really is a bottleneck in the amount of capacity that's available. It's being not only underutilized, but there just isn't enough of it. And so that's what really got us, that's what's catalyzed so much of our work in the last year, is seeing very starkly the lack of capacity to usher in this materials transition and
Right.
what will ultimately stymie the materials transition.
And we'll come back to what some of those building or those stepping stones were to get to that place of how you built that, the same way that I'm going to talk to everybody about their stepping stones. But so Alex, so to get to Keel Fibers, first of all, I know you had a name change, but then, you were with some of your schoolmates, basically your college friends, I believe. And is that where the idea started? And then, and how could you even have the audacity to think that you could turn, did it start with seaweed? Did it start with kelp? You're on mute.
That's correct. We did get started while we were students. Before I get into that, Josh, I'm super curious about this catalog you put together. So please send more info on that. But yeah, so as far as Keel goes, when we were students, I mean, we were also getting exposed to the industry, and it became really clear that there was a need for these materials, even at that level, right? And even at the student level, it became really obvious. And there was so much conversation around sustainability at that point, a lot of discussions around 2020 goals and how we were going to reduce our impact. But yeah, there was very little, I think, ways of making that happen. And so as designers, we were like, well, the best place to start is with the raw material inputs to the products that we create. And for us, we wanted to create a fiber, which we felt like was a very applicable product in various end products and in various industries. And then fibers can be spun into yarns, which are often woven into textiles or knit into textiles, et cetera. And so we didn't necessarily start with seaweed, but we knew exactly what we wanted our end product to look like, either a fiber or yarn. And that is what allowed us to really dive into the exploration and look at bio-based raw materials that we could utilize. And through trial and error, we just kind of came across seaweed. And seaweed
Were
really
you mostly focused on plant-based things, or was it just completely wide open?
It was mostly plant-based, and it was mostly ocean-inspired even at that stage.
Okay.
But we just zeroed in on seaweed for many reasons, including sort of the appeal that there was around seaweed and its sustainability impact, but also around the fact that there was a supply chain already built around it at a commercial level.
That's so smart. Okay. Yeah. Because of the food.
Yeah,
right?
food
And
is a huge industry. Yeah.
Okay. Yeah. All right. That's interesting. So Zimri, Zimri, I know about some of your challenges, but I would love you to share some of the early challenges, because they're just things that people don't think of. There's one thing, you started off in fermentation, but then you shifted. And so take us through a little bit of that journey about why you switched and pivoted and had to find new people. And
Yeah, absolutely. And I remember, hold on, sorry. we have technicians here who are revitalizing some of our machinery, and it's a laboratory, so things are
it
happening.
keeps it real. I think it's
It
good.
keeps it real. Yeah, I'm really here. We're really doing it. We're scaling.
We're scaling up right behind me.
Yeah, we're scaling up right next door. But to answer your question here, yeah, and I remember meeting with you with our very first textiles in New York City, in Soho. And it's true, we were fermenting them just in the Upper East Side in a very small room that didn't smell great at that time because it was filled with kombucha. And we realized, I think, through that experience in New York, that scaling our own raw materials, our own inputs, was going to meet a lot of those limitations that Joshua was speaking to, that there wasn't enough capacity, that we didn't have that necessarily expertise, that we were really, really good at creating a material that brands wanted. We were really good at that science, that product discovery, that product engineering, but we weren't necessarily experts at scaling up a raw material to feed into that. And so that led to a huge change in the company, where we shifted entirely away from fermentation, from actually growing our own things, to really focusing on that composite material technology, the chemistry, and all that entails. And that also signified our move to Houston from New York City to tap into that talent. And that's where we've been since. So.
But you also had the added challenge because you're a very curious person. You're a natural born entrepreneur, but you're not a chemist, right? You're not a scientist, but you know how to find people. And
yeah, that's right. My biggest accomplishment as an entrepreneur is finding extremely talented and skilled and mission-driven people. And so we definitely have that here in Texas. We have an amazing team of chemists, PhD chemists, engineers who know this stuff a lot better than I do. However, I will say that I just finished auditing organic chemistry from Rice University last semester, which, I mean, it's still very, very hard for me, but I'm understanding a little bit more every day.
That's awesome. Thank you. Okay, Martin. So you have a great story, and I'm not even sure where to start with you, but I'll just start with like the early challenges, because I'll just give everyone a little bit of insight. You started working on a different material, different product altogether for someone else, and then you had an idea to start something. And so just sort of, we'll land there and take us through some of those first challenges that you had.
Absolutely. Thank you. Thank you for sharing, everybody. Alex, I was impressed by your story. I wish I would have been that dedicated and mission-driven as a student. I was not. I was exploring many different avenues, from agriculture to mechanical engineering, chemical engineering, and biotech. And once I graduated, I discovered, hey, they don't really line up to a very easy job. So I did what everybody does when they're searching for purpose. I moved to California to join a mycelium startup in the Bay Area. And that was a really good experience. Seeing these very first days of a new industry was fascinating to me. And Thomasine, maybe I can provide here a segue into your
Please.
question.
Yeah, please. Yeah.
Seeing this industry and then moving to a tannery in the next phase of our company as history basically showed me, hey, there's still a lot of fur animals being processed in the tanning world. We process leather, we process tanneries. I was planning on staying in this tannery for about 2 weeks in 2020. And once COVID came around and kind of locked down most of Europe for a very long time, I stayed in this tannery on the ground floor, working with the people for about a year. Unexpected, but provided some very important insights into how BioFluff evolved over the next couple of months and years.
Mm-hmm. Right. And so you were working in a tannery that tans animal hides,
Mm-hmm.
but yet you were there for a next-gen material to take a tanning process. And then you pivoted to an entirely different material or fiber altogether, realizing, so you recognized that you could use that existing equipment.
Yes.
Yes.
I would say the biggest lesson I've learned in this tannery was new technologies and old technologies can coexist and co-develop together. And that was the important lesson I learned from my first job. I was like, we got this super cool new technology, and we got this century-old heritage that people are passing down for generations. In my case, it was in Spain, in northern Spain, in Catalonia. And just seeing these two industries merge and see how they communicate, where the challenges were, and how they would collaborate to create a completely new material was fascinating. And I used this as a blueprint for BioFluff, which also combines completely new fiber technology with century-old fur technology.
Mm-hmm. Alex, well, and we'll come back to that, Martin, because I think that working, basically your lab was inside of a factory, because most people are starting in labs, and then that's one of the biggest challenges. How do you take this little kitchen counter idea and then be able to scale it up? But before we go deeply into that, I wanted to come back to you, Alex, and ask you, and this actually, maybe this does start to touch on that, because you had an idea, Alex, with your colleagues about a fiber. You wanted to make a fiber. Were you thinking about equipment at that point? I mean, you were working, so where were you working? Were you in a lab space? What was your facility?
Yeah. We kind of set certain parameters for ourselves from the get-go, which included the end product that we wanted and the manufacturing system around it as well. And so we knew or work with the material, but rather making it super seamless was our goal. And at the time when we got started, we were working in our apartments, in whatever space we had access to. Eventually, we got into an accelerator that gave us some of the lab space that we were lacking. And then from there, just evolved to where we are today, which is in North Carolina.
Okay. That you definitely fast forwarded on that one.
Took a couple years.
Yeah, a couple of years, because I think you're about 5 years old. Is that right?
Yeah.
Your business? Okay. So we'll go back to some of those earlier stages too. So Zimri, how about you? So you had not only an input or a feedstock sort of switch, which requires one sort of one type of equipment, but then you switched over, which is a whole whole different set of equipment and equipment challenges. Can you tell me about how do you address those challenges? I guess it would, again, since you didn't come from that world, you're not a mechanical engineer or a chemical engineer. Tell me about how you address those challenges of once you decided to make a different material that wasn't a fermented product.
Yeah, definitely. And by the way, chemical engineering, that's my next RICE course. That's next semester. we'll get there. But yeah, for now, I don't have that background. But luckily, Dr. Carolina Amin-Faril here, our CTO, does have that background. I think the hard part, and like Alex, we're looking to slot into existing machinery. We thought it was really important to design our process, our materials to be compatible with things that already exist. And it kind of touches on what Martin was saying as well, where you have compatibility between new technology and heritage technology. You need these kind of intermediate steps to achieve real impact faster. It's harder to invent both sides of a process simultaneously. I think it's a lot easier just to create one. And so I think for us, we're also toll manufacturing everything we're creating. So we're not doing any of it ourselves. Investors don't like investing in CapEx. Neither do we. We want this to be easy, to be smooth. A lot of these tool manufacturers are too big. They won't work with us yet. They won't help us kind of go from 0 to 1,000. And additionally, for our own lab scale equipment here in Houston, the lead times can be 6+ months. And so it can take a while to get off the ground, get running, and get the kind of technical support that you need to start working with this. Luckily, once you have it, we do have it now, and we've had it for a little bit. You have access to experts all around the world that know this technology really, really well. So if it breaks down or if you have issues, you have thousands of experts you can call, which isn't the case if you're trying to invent your own kind of scaling machinery.
Mm-hmm. Do you all find that there's a certain amount of collaboration in the innovation world? And Joshua, I would include you in that as well. You guys can unmute yourself if you don't mind.
Yeah, I think there is a certain degree of that. I firmly believe that there's not one solution that's a part of this revolution. It's multiple, and having everyone come together to develop these different innovations is going to have the ultimate impact that we're trying to target in terms of sustainability and climate change. But there are so many different differentiators between all of our technologies that it also, limits a collaboration to a degree. But I would love to see all of our products together at some point. I think that's amazing.
We'll design a line. Joshua, tell me I want to know about how you go about, so since you have clients, right? You have clients who are material innovators. You have clients who are using fermentation to create fibers or materials. So does that mean you also help them with their equipment challenges when they go from lab, pilot lab to next step?
We help companies essentially get their bioproduct to market, and that usually involves producing at commercial scale. That almost always involves producing at commercial scale. And we should be honest about the fact that these products, by and large, are not on the market. And that's true not only of materials, but that's true in food and chemicals as well. There's so many different applications that companies are pursuing, but they're by no means ubiquitous or even meaningful percentages of any supply chain in any product category that I know of. And so we help. And we believe that the reason for that is because they can't yet be produced economically relative to prevailing products. The problem with all of this, of course, is that everyone here is producing something that already has an existing analog. And so price parity is the only thing that matters. Over time, we're hopefully the innovators that we've seen in the last sort of day here and on this call will be producing products superior. We functionally use the things that we use, say in fashion. We use goose down because it's warm, it's good, and it's cheap. It has all sorts of horrible ancillary problems, but it has a market price for better or for worse, and it has a certain set of functional properties. And until you can meet or exceed those functional properties and meet and exceed those price, you will not get uptake by and large. And that's just the commercial reality of this. And the only way to meet commercial pricing is to actually have capacity that scales. And so that's really where we come in. We work with companies to say, hey, what is your product? So you have anything from a PHA or a spider protein you mentioned, like a material. What are the economics of your bioprocess? How big a facility do you need to sell for whatever the prevailing price is of whatever you're selling? And I think the elephant in the room here is the offtake, that everyone here wants Nike or Lululemon or Zara or Uniqlo to come along and say, hey, I want to produce, I want to feature this. I will buy X number of tons next year at this price. A problem of scale is ultimately a problem of offtake, because if there is offtake and if there is absolute clear demand, the market will respond with the financing necessary to produce your product at scale. And so part of the challenge that we see, and that the gap that we're trying to close, is that demonstrated offtake. And this is, again, true in climate in general. This is the whole idea of advanced market commitments, that it's very hard for us to produce the sort of tools that we need at large scale to fight climate change without the offtake from the really big players to say, we will buy whatever the offtake is, whether it's a ton of carbon, or a gigawatt of clean energy, or whatever it is that offtake is, or a kilo of BioFluff or something like that, right? So we need those offtakes, and we work with companies to at least get the capacity side done and help them get over that hurdle.
So what is your staff like, Joshua? Like, who are the people? Like, what are their expertises?
We have two
to
broad
get
challenges
to the scalable place.
Yeah, we have two broad challenges in getting capacity. Well, three in getting capacity up and running, and it's reflected in our team. The first is the actual designs of the facilities that we're bringing online, and understanding what these facilities look like and how they can adapt to work for the largest number of potential tenants. That in order to be a financeable asset, in order to be any asset, but especially in order to be a financeable real estate asset, you have to have a degree of fungibility. You have to have a degree. Something says, look, if Alexis is producing at our facility, and for whatever reason she needs to produce at another facility or scale down or something, someone else can come in and produce in that facility. The facility value itself won't go to zero. And so we have a pretty amazing science and engineering team that works on the facility designs that allows those facilities to have that degree of fungibility across companies. And then the flip side of that is our capital markets team, which is really saying, okay, this is what's going to make companies into this facility underwritable. That we're going to allow we can credibly say we can put them in a facility and they'll be able to pay the rent. Everyone goes through underwriting processes when we buy a house, when we put down a down payment for commercial office spaces. Everyone here has done. The owner of whatever that asset is that you're leasing wants some confidence in knowing that you'll be able to pay the rent. And no different in this asset, no different as we bring these new assets online. So we have a sort of science and engineering team to underwrite the science and technology of the companies coming into these facilities, and a pure capital markets team to underwrite the capital markets risk, and to work with our capital markets partners, to work with the infrastructure and private equity players who want access to this new green asset class, who want access to the transformational supply chains that are happening, but don't quite have the appetite for investing in specific individual companies. Those two pieces are what comprise the majority of our team. And then obviously the development folks to actually bring this capacity online. That's the third piece of actually developing the site selection, the permitting, all of the things that are involved in getting new sites up and running. It's a pretty extensive process and a daunting one to any individual company, and one that, in the same way that they don't build data centers for their email or software, they shouldn't be building these facilities for their products.
So if I could interject, because you mentioned the word capital quite a few times, and that's definitely something I wanted to touch on, that money, I would think, is a huge challenge in being able to scale and being able to get access to money and how people get money. And so Martin, do you want start talking about money and how that enables you, or how it can slow things down, or how you plan for that?
Mm-hmm. So with respect to the BioFluff process, we have 0 CapEx. That's how we designed the process from the onset. Every process step is outsourced to a different contract manufacturing partner at the moment. We might bring specific capacities in-house at one point in the future. As Zimri has said earlier, investors really don't want to see CapEx on your term sheet, so it's just not something we're focused on right now. But
I'm sorry, what are CapEx? I don't know what that is.
Capital expenditure, basically buying a specific machine.
I'm not an entrepreneur.
You would buy, for example, machine A. I know Zimri would know much more about this with his finance degree. Zimri, do you want to jump in?
Yeah, no, you pretty much got it, Martin. CapEx is just purchasing a factory, purchasing a piece of equipment, actually owning the means of production of what you're doing. That's what CapEx is, and investors don't necessarily like investing in it because it's a huge amount of cost upfront without a guarantee that your process is going to work. So it's a huge risk for their money.
Right. That's kind of what Joshua was just saying about, it's like getting any sort of a loan. They want to know what you have. I see. Okay. Thank you. And then, but in terms of raising money, because to get the equipment, to get the skilled people to work using the equipment. I mean, everybody might believe in the mission, and everybody might be all aligned and kumbaya on sustainability and new materials, but everybody wants to get paid. And so I guess the onus is on you to basically become salespeople to pitch these ideas, and that's why they should give you money.
Yeah, there's no secret here. You define the mission, you build an early team, you do your best with the limited resources you have, building some sort of early MVP, minimal viable product to show to investors, and then you take it from there. In our case, we built an MVP already at the industrial level. So the way I approached the problem was I was visiting different factories across Europe. There often it's hard to get a hold of factories, as especially in the textile business, they are secretive about their process. It took a lot of traveling. It took maybe some trespassing with a bottle of wine to visit people in a factory. But yeah, the BioFluff process really was designed on existing machinery. So we were not starting with a lab prototype, but we would start with, hey, which machines are out there? How are they utilized? What is their distribution throughout Europe? What's their energy efficiency? So we would take all these considerations into how we designed the BioFluff process.
Okay. And so, Alex, you were looking for spinners, right? You had to find, I guess, wet spinners that suited your fiber you were developing. Yeah. Was that hard to do? Because from what I understand, they're not so readily available.
Yeah, I mean, there's, I think there's some stuff I want to touch on that Joshua was also talking about, and Zimri in terms of material access or equipment access. But yeah, our process is a wet spinning process, and wet spinning is an industrial process used to produce mostly cellulosic-based fibers. So it's available, but it's usually available at extremely large scales. Or maybe you can find something through a research institution, but then you're kind of tied to schedules that work for them and not necessarily that work for you. And you're paying a huge premium to be able to access their equipment. And so I think there's a real important balance in terms of owning versus contracting. And I think, ownership becomes less of a risk over time as your process gets more refined and is closer to commercialization.
Okay. So I'm assuming that takes quite a bit of time to find that type of equipment you're talking about. So not the super large, like high capacity version, but the one that's small. So is it somewhere between pilot phase and small production run phase? Is that?
Yeah, exactly. And you need something even smaller scale to test your product in-house, right? So
Right.
I mean, all scales are necessary. You need
Right.
access to all scales.
Right. Right. I have a question here from someone in the audience, Marina. I'll just say the question. We'll see who feels best suited to it. What stage of the research or the TRL level did you start developing products in partnership with clients? Oh, this is a great segue because we haven't gotten to the brand partnership part yet. So thank you, Marina. So what stage of the research, meaning your TRL level, did you start developing products in partnership with clients? Zimri, how about you?
Yeah, sure. So like the very practical answer is as soon as they will start working with it, like I think as soon as you have the idea, as soon as you have a prototype, you're out there trying to find clients. I think the more co-development you can do the earlier on, the more you can have a partner buying into what you're doing, the more you can fine tune it to exactly their specifications. I think the better chance you have of actually making it to market and creating something that they want to use in their products. So I would say the earlier, the better. I think the earlier, the more challenging. I think a lot of brands today are wanting something. They don't want to co-develop necessarily. They want something off the shelf, ready to go. You need to be working on that too. But I think there are a select number of partners that are willing to work with startups earlier and earlier and be part of that journey. So I would say that finding those partners as early as you can. As soon as you have, I wouldn't say your first prototype, but maybe your fourth or fifth.
Yeah. Martin, how about your experience with developing products with brands in partnership?
As early as possible. In my opinion, there's actually no real break, or there's no transition between doing early market research, building an MVP, and showcasing product to potential customers.
Well, probably people won't co-develop with you until they see some sort of proof of concept, right? I mean,
that's true. An official joint development would take definitely some sort of product readiness, but ideally you want to have these people involved as early as possible, so that they can provide their feedback, provide their opinions, give you some feedback on where to go next, which quality aspects.
And do you feel like this moves it along more quickly? Do you feel like working with a brand partner or two or three moves the process more quickly?
There's definitely a balance of how many brand partners you can juggle at the same time. But right. Yes, to a certain extent, working with multiple brands at the same time definitely helps you progress faster.
That's actually a really interesting point, because I'm sure brands require a lot of time and attention. And so I could see how that would really, that could be a lot of pressure just for, staffing wise, just to try to manage the person who's managing the brand, and then dealing with the swatches you have, or the runs that you've made, et cetera. So that seems complicated.
Maybe I can quickly chime in here. This is something I've also learned from my previous company. Having a person close to your customers, working with them maybe on a daily, on a weekly basis, being there in person really helps a lot. So we have now a BioFluff person, Ronnie, in Paris, who is working with our luxury clients every day. Whenever she receives new material, she showcases it to them as fast as possible to really minimize the turnaround.
Right. So that's one of the aspects of scaling. Obviously, it's like most of your energy initially goes into the product, the creation of the thing you're making, but then you need someone to field the calls, right? Someone who has the product knowledge, who understands where it's going, and who knows how to speak with whether the brand is an auto, fashion, or from the home industry. So that's also quite important. I wanted to ask you about, because you've all moved into a stage, and Joshua, this is including you, although yours is a little bit less specific. This is a geographical question. So you've all made moves as to where you want your business to be. So there's like an office headquarters, and then there's where you might actually have your facility. So Alex, you've already talked about it, but if you could say it again about how and why you made the decision you made. And
Right. Yeah. So we originally started in Brooklyn, New York, where we had a lab facility, and we were just kind of all there, all staff, whether it was marketing or researchers. And then we quickly realized we were outgrowing that space and we needed something that could accommodate slightly larger equipment that we could trial our new formulations on. And based on our needs for the future and talent that we were hiring, we decided to relocate to North Carolina, which happens to be a state that's deeply rooted in textile history and also has the last college around textiles present in it, which is NC State. And so we felt like that was the right move for us. We were also working with partners locally to that area and just saw potential in being in North Carolina for down the line.
Yeah. Zimri, will you please tell us about your moves?
Yeah, totally. And I want to highlight something that's really interesting about like all three of the next gen materials companies that you have on this panel is that they all share one of their first major investors, which is SOSV's IndieBio. And New York City is a part of the history of all three of these companies. And it was certainly the start of our company in the Upper East Side in the Rockefeller University. And I think that after a year of that program, we realized that the next stage of this, as well as that kind of transition that we're making, required a place where we could kind of grow more sustainably. And for us, that was Houston. So, there's a lot of oil and gas talent here. There's a lot of infrastructure here. Joshua talked about the energy transition. Those are big words in Houston, and they're big words with the talent that's here. But not all of that talent kind of shares some of the same values. And so we're looking for those diamonds, those people who maybe don't have those values, who maybe are looking for something different, who are willing to make a serious impact on the world and be involved in a startup. And that's primarily why we chose Houston, is for the people.
Cool. And Joshua, you're based in New York City. Do you feel like your business could be based anywhere? Or do you feel like because of New York being a hub of fashion, not necessarily material development, but fashion and banking, do you feel that New York makes sense for those reasons?
Yeah, it's definitely a hub of the capital markets. And so it's important that we have, I think, a locus here. Rather, our headquarters is here, but we have people all over the country and a couple in Europe as well. For us, there's always this aspect of designed in California, made somewhere else kind of thing. Not that we have a team in California, but the sort of paradigm of, hey, we're designing and working and ultimately financing these facilities, but these facilities obviously won't be in major urban centers. And I think it's important, if it hasn't been clear so far, we're working primarily in fermentation, which is different than what some of the other products folks on this call are doing, and what many others doing amazing work in material innovation are doing. So in a biological process, you need a few things that make you a poor candidate for being in any major urban areas. You need things like lots and lots of power and lots of water and acreage and all sorts of stuff that just doesn't make sense to put anywhere near a major, a really huge urban area. And so likely our first facilities will be in the American Midwest. And so for us, there'll be we'll have sort of a combination of folks in places like New York and California, but a lot of people also on the ground in places like Kansas and Illinois and Indiana and places like that.
Interesting. Thank you. And Martin, you've already spoken about, you started in California, and now you have an office in Paris, which I think everyone could understand why that makes sense. But then where you're actually making your material is where? Your fiber, your fur.
We are producing BioFluff currently with a completely European supply chain. The majority of our work is done in Italy right now, where we've identified the best cost to time ratio for the machines that we need for our process. But the rest of our team is completely remote, spread somewhere across the US and Europe.
Okay. Martin, you had mentioned something to me at a previous conversation about, since we're talking about scaling, as you start to scale with your BioFluff product, you sometimes run into problems with because making 100 meters of something, can be perfect, but complications can happen when you're making 10,000 meters of it. The quality can suffer, or something happens with the machinery or the inputs, et cetera. So, and I want to ask this question of Alex and Zimri as well, but Martin, if you could start by talking about, you had mentioned you have capacity, you have quite a large capacity, but you're keeping it low right now so you can manage basically the QC, right?
Mm-hmm.
Is that still correct?
Exactly. In terms of manufacturing, it's many things scale linear. Biology definitely doesn't scale linear. Everyone here who has tried to grow stuff or ferment stuff knows that biology or any biological process does not scale linear with the amount of volume you're fermenting or the amount of meters you're producing. So the way BioFluff is trying to combat this challenge is basically by using technology that scales linearly, such as a mechanical process or a chemical process, where we are letting letting the plants do the biological work, and then our processing is very much focused on a process we can scale linearly to avoid these bottlenecks. Does this answer your question, Thomasine?
Well, no, but that was interesting. I was wondering, because I think that when you start scaling in terms of meters, thousands and thousands of meters, things can happen. Like if I'm to think of a yarn, and Alex could probably jump in on this, suddenly this yarn that you had at a certain thickness or certain thinness is getting irregular, it's getting uneven, or it's the twist is coming out or something like that. So I'm wondering if has a version of that happened to you as you try to run thousands of meters of BioFluff versus, we're doing 100 meters here.
Yeah.
Has that happened or no?
Not really. That's one reason why we designed the process in a way to have no biological activity in the main manufacturing step. In the past, I might have worked with, let's say, technologies that had a major biological aspect to the main manufacturing step. Mm-hmm. And they're exactly what you were mentioning, like producing a square inch can work really fast and really well. Producing a square foot can be challenging, but be possible. Mm-hmm. And then already scaling from 1 square foot to 3 is impossible, because suddenly there are biological factors kicking in, temperature, other gas balances you have to consider.
Right.
Yeah.
So Alex, as you've tried to increase your capacity, have there been hiccups along the way with shut the machines down? It's like it just broke, or something snapped, or?
Yeah, definitely. All our equipment in-house is modeled by commercial wet spinning lines. So we've done that intentionally so that when we get to the commercial scale, that we know what to expect. Mm-hmm. But nonetheless, when you go from producing, in our case, 1 filament, which is the smallest scale we ever produce at, where we're testing new formulations, to producing 10 filaments, to then producing thousands of filaments, you run into challenges. At every stage you go up, there's always going to be a challenge. And then you work through it and you get your processing right. And hopefully from there, it's running smooth. But I think at every incremental upgrade in terms of production, we have experienced small challenges.
Okay. Zimri, I wanted to ask you that too, but there's another question I want to get in, and I'm going to start with you because we're running out of time. And I wanted to ask you about your supply chains. This was actually mentioned in some of the other conversations as well with the synthetics discussion, but you're all working with such non-traditional supply chains for the types of products you're making. So Zimri, I could start with you with the difficulty or the challenges of accessing supply chains and having the continuity and the consistency and reliability. And I would love everyone to weigh in on this too. So.
Yeah, especially when you're getting materials from all over the world, like we are, and it's first of all, it's hard to get suppliers sometimes to take you as seriously as you'd like. With the quantities.
Why is that? Why won't they take you seriously?
Because you're a new game, and a lot of these suppliers, already have some of the materials we use, even biological materials, are currently used for oil fracking. They have that capacity reserved for 5-10 years. So you're coming in saying, I'm doing something new, take a risk on me. And I think it's a lot about telling that story about about how you're going to grow, about why it's meaningful for the environment, the impact.
Mhm.
And a lot of them, especially if they're more innovative, will listen to that story. So I think first is just capturing their attention. And second is transporting a material from site A to site B. And that's not an easy thing either, especially if you don't have a dedicated supply chain manager. And I think that's been hard for us as a smaller team, is that we don't have someone specifically dedicated to that full time. So a lot of those responsibilities are now on our technical staff to literally try and work with a customs broker to get tons of material from the Port of Houston to our laboratory and facilities and a pilot manufacturing here in the East End. And that's not a simple thing. And we did wait. For the first time we tried to do that, we did wait 2 months. And I went to the Port of Houston and argued with them about, please let yes, I know I did the wrong form, but please let our materials into the country. So I think that's going to happen.
I completely agree with Zimri. If anyone could figure out supply chain issues for startups, I would be a very big fan of that person.
Joshua, can you help them? So Martin, so you're using plant waste, right? And it's agricultural for the most part, and some may be grown at this point, or maybe you're past that point now because you are. And we're going to end this with finding out where everybody is with their commercialization, which we got to kind of do in the next couple of minutes. So Martin, if you could just talk briefly about your supply chain pains, and then talk about commercialization when you anticipate.
Yeah, supply chain pains are real. Being a US company, moving raw material in Europe, manufacturing in Europe is definitely a big challenge. And we're still looking for good solutions. Like, we're finding small tricks and solutions every day. But yeah, it's an ongoing battle. In terms of commercialization, just to wrap it up here, we're currently creating a capsule collection with one of our luxury partners, which will be hopefully presented in October at the Paris Fashion Week. Thank you. BioFluff is out there. Thank you.
That's very exciting. Alex, how about you? So first of all, supply chain issues, but yet you're putting a factory in North Carolina. Your kelp is a major input. Did you just consider using a coastal location at first, or shipping and trucking is fine? And
yeah, I don't think I'll have time to get into all of the details here. But we, just going back to what I was saying earlier, we specifically wanted to work with seaweed because of the existing supply chain. So we've been able to tap into that and source our raw materials through those channels. And we've had partners that have been very willing to work with us, and some companies that just haven't been because of our scale, as Zimri also has experienced. And in terms of commercialization, we're working through some brand pilots right now, and are working our way up to commercialization. We still have a long road ahead of us, but we've made some really incredible progress this year alone.
Okay. Lastly, Zimri, any commercial products coming up this year? And then I have to go to my closing. I'm so sorry to make it so quick.
I would say that we're right now this year we're really focused on creating pellets of our material, making them a lot larger. We're aiming to do 45 centimeters next month. We're aiming to do even larger, like a meter later this year. So, and by many meters long. And so right now that's our primary focus. We're very much in development with a lot of different brands, and I would say that next year we're looking to bring something to market.
Thank you all, and Joshua, thank you for joining us and adding this unusual level of expertise that you bring, certainly new to my background. Thank you all. I'm going to close us out now, and thanks.
Thank you.
So today we've just finished our second day of the conference. Thank you, everyone. I'm going to try to do a brief recap of what we heard and learned. So many notes. Earlier today, at the beginning, we learned about diversification as a smart business practice, as a way to keep up with sustainability demands, and the importance of being adaptable during these times, from both the material creation all the way to manufacturing. And we listened in on a very, very complicated discussion led masterfully by Brooke Roberts-Islam on end-of-life circularity, made even more complicated by the majority of blended fibers we have out there in the world. We also heard about value chains and building a new economy built on circularity recognizing all of the different stakeholders involved with circularity. We learned about the really interesting work being done to study microfiber shedding and how to end it, and thinking on such a granular level to like yarn twists, the diameter of the yarn, the heat and finishing process is really granular stuff. And then what was the succession plan, or what is the succession plan for current synthetics, which was a really dynamic discussion that had my head hurting and exploding in so many different ways with a great panel. We heard several different solutions actually from this panel as they finished up and what they're doing. And we're actually going to hear a few more solutions tomorrow regarding synthetics. So lastly, I just want to say that with this panel we just finished, thank you all. And I'm so happy you're doing what you're doing. And Joshua, I'm so glad that you've always had an interest in biology. So these people are at the forefront of the materials revolution, and they're building an industry from the ground up, from labs to factories. And despite how it feels for all of us who are, you know, whether we're consumers or brands from the fashion, home, or auto industry, it's actually moving quite quickly. I know we're all impatient, but just remember the DuPont scientist and how they needed 10 years to launch something. So we're on track, and in many ways, in most ways, we're ahead of that schedule. So it's moving quickly, progress over perfection, and we are getting there. Tomorrow, we're going to cover much more. Have a great evening, everyone. Bye.